10, 9, 8. Ignition sequence start. Engines armed. 5, 4, 3, 1. All engines running. Launch command.
Hey there everyone. We all know the gas giant Saturn and its beautiful and iconic rings. Now let me show you another planet. Can you tell me which planet it is? I'll give you some time to think. Now you might not believe it, but this is also Saturn. Now you might be asking, how is this even Saturn? It doesn't have its rings. So this might surprise you, but Saturn wasn't born with its rings, but it actually got them somewhere in its history. So today we'll be discussing how Saturn got its rings and some proofs for the theories. Now there are two of Saturn's moons which are related to the formation of its rings, which we will be discussing. The first moon is Chrysalis. Now this moon's existence is not confirmed, but it is a hypothetical moon which can explain the theory which we will be discussing. Now the second moon is Enceladus. This moon is existing right now and we have proofs of it contributing to Saturn's E-ring. More on E-rings will be discussed later. Okay, so now we will be discussing about Chrysalis and how it contributed to Saturn's rings. Now this is just a theory and it is not confirmed by scientists since we do not have any solid theory with enough proof to confirm 100% that it is true. But this is currently what scientists think happened. So there is basically an invisible boundary around Saturn, which is called Saturn's Roche limit, spelled out Roche. So when an object enters this Roche limit, Saturn's gravity is so strong that it will basically start to tear that object apart on different rates based on the mass of the object. So what happened to Chrysalis was that over time its orbit deteriorated and it entered Saturn's Roche limit. So what happened when Chrysalis got this close to Saturn is that Saturn's gravity basically just started to tear Chrysalis apart, like you can see in the video I am showing here. So all these icy particles and rocks which are coming out of Chrysalis as it is being broken will later form Saturn's rings. So after Chrysalis basically was torn apart, all these pieces of ice were traveling at a really fast speed, and it took them only a matter of days to spread far apart and encircle the entire planet of Saturn. Just so you know, after Chrysalis was broken apart, most of it was swallowed by Saturn, but the rest of the pieces that were left behind ended up forming the rings. Right, so now that we know how Saturn's rings were formed, there is one thing that you should keep note of. Now, Chrysalis might have been torn apart by Saturn's gravity, but some people also say that it could have crashed with another moon, maybe even multiple collisions with multiple moons. So, we're still pretty unsure on how it happened. So now here we have a diagram of another one of Saturn's moons called Enceladus. Now as we can see, Enceladus has an icy crust and a rocky core. But between its crust and core lies a subsurface ocean. So in the south pole of Enceladus, you can see that there are jets shooting out particles of water and ice from this ocean, which is one of the ways we know it exists. Now, these water and ice particles, which are shot out of Enceladus's oceans, will eventually float away from it and collect in Saturn's E-ring. You can see Saturn's E-ring here, which is the faint outer ring made up of tiny ice and water particles. Now, as I said before, that these theories are just theories and they don't have much proof. So, what proof, or maybe even little proof, do we actually have that can suggest that these theories might be true? So, most of the proofs and observations were collected by the Cassini spacecraft, which went to Saturn. Now, this spacecraft helped us to calculate the age of Saturn's rings, which helped us find out that it is actually quite young, maybe found just 100 million years ago, compared to Saturn, which was found 4.5 billion years ago. And the predicted age of the breaking apart of Chrysalis matches the age of these rings. So, that is one proof we have. And as for Enceladus, well, we know that because of the observations made by the Cassini spacecraft, and we also know about Enceladus's structure because of these same observations.